Good morning, ladies and gentlemen. My name is Miroslav Hanák. I work for Sentinel and I'm going together with my colleague Martin Prudek present you about Turris Sentinel, our data collecting system, and how do we collect network data from thousands of devices across the internet in practice. First of all, I'm going to introduce you Turris and then Sentinel, and in my last part of this presentation I'm going to talk about Minipots, one of the parts of Sentinel. After that, Martin will have speech about data pipelines and Sentinel outputs. Turris originated as a research project, which purpose was to find out whether people only connected to internet are targets of cyber attacks. For that purpose, we created Turris routers, which served as a network probes. They had some nice features as a powerful hardware. They were free open source. They had automatic updates, and also we gave root account to people. And we rented those devices for symbolic price to various people and institutions, so we could just collect some data. We wanted to know about attacks made to devices, so we were collecting firewall logs and also data from traps on attackers from honeypots. There were also some attempts to do anonymized traffic statistic, but this showed to be problematic since we were missing context and content of outgoing communication, and we also didn't want to spy on our users. From collected data, we could detect malicious IP addresses. After some time, idea of automatic blocking of malicious IP addresses raised, and we created dynamic adaptive firewall. Thanks to all of the nice features of original device with the research purpose, Turris routers transferred to commercially available devices. We introduced new models such as Turris Omnia and Turris Mox, which included even more nice features. We have growing user community, and since the purpose of this device is not anymore purely research, data collection is optional. Finally, now I am getting to the main topic of our presentation, to Sentinel. Thanks to it, we collect plenty of data from thousands of Turris devices across the whole internet. Internet is a wide place, so all the communications with Turris routers and devices are secured by TLS and certificates. There is dedicated subsystem certificate authority which automates issuing of certificates for Turris routers. Sentinel is designed as a microservice architecture, so each component is loosely coupled to others and independent. So each component does one small functionality well. So whole system is modular and it's possible to very easily add new functionalities. It's also highly maintainable, and it allows for hardware and software scalability, so we can always add new instances and more powerful hardware. Collected data are processed in real time while flowing through data pipelines. This is achieved by using message queue technologies, and my colleague Martin is going to tell you more about this. Sentinel has several outputs. The main one is dynamic firewall. There is a one-day snapshot of blocked IP addresses called gray list. We also have SView, a web interface where you can see basic statistics, analysis of collected data, and also a release is available there. Here on this picture you can see how Sentinel and Dynamic firewall work together. First of all, we capture data about cyberattacks on routers. As I already told you, we collect firewall logs and we also collect data from our Minipots. What is Minipot? I'm going to tell you in few moments. Of course, all the data are sent to our servers. At our servers, data are processed and analyzed. Each IP address gets a score. The score is calculated based not only from captured data, but also from data from external resources. We have HAS, which is SSH honeypot as a service. After that, score of each IP address is evaluated and we decide whether given IP address is malicious, whether it deserves to be blocked. By this, we obtain a list of bad IP addresses. The list of bad IP addresses is then shared with all our routers, which update their firewall rules. So, all bad IP addresses are blocked on all our routers. Now you know the main working principle of Sentinel and Dynamic firewall. So it's obvious the more devices are participating in our data collection, the more data we get, and we are able to block more bad IP addresses. As I already promised you, now I'm going to tell you what is Minipot. Minipot is our internal shortcut for minimal honeypot and name one of our Sentinel component. Honeypot is trap on attacker, where attacker thinks he got access to some system or service, but instead he's in controlled environment and all his steps are recorded. Minimal in our context means that we are just interested in a connection and a login attempts made by attacker to our Minipot. Practically, we are waiting that someone connects to our Minipot. After a new connection is established, we ask about authentication data. We let an attacker to insert credentials few times, and after some predefinite count of unsuccessful login attempts, we close the connection, as normally configured servers do. All the connection and login attempts are logged and sent to our server data pipeline. Minipot is the main Sentinel's data source and also a most complex Sentinel's component. We wanted to avoid fingerprinting of our Minipots, so we based their designs not directly on protocol standards, but on communication patterns of most used server implementation. Because if we use the protocol standards, we could create easily recognizable and unique solution. An attacker has no access to real system, so users running our Minipots are safe. Also, the emulation requires just a low amount of system resources. From the early days of Turris, there was a Telnet Minipot. And since end of this July, we have 3 new HTTP, FTP and SMTP Minipots. As I already mentioned, Telnet Minipot is with us from early days of Project Turris. Telnet protocol is not standard application layer protocol in means of it doesn't provide transfer of files, but it is designed to provide access to command line interface on a remote network host. Telnet is a very old protocol with so many security issues. All the data are sent in plain text. There is no authentication defined by the protocol. Query for login and authentication data are just user data from protocol's point of view. So we collect username and password by just sending prompt for it. Telnet Minipot is very simple. It's actually the simplest of all of our Minipots. HTTP Minipot. HTTP is widely used and spread protocol. It is base of World Wide Web. It is stateless request response protocol where each request is independent of each other. From each HTTP message or request, we collect method, URL, user agent, and username and password provided by basic authentication scheme. From implementation point of view, most of the functionality of HTTP Minipot lies in complex HTTP message processing. HTTP message contains request line, many headers, and then it can also have body, which can be static or chunked. Protocol implementation itself is very easy. As I told you, each request is independent of each other, so we don't have to remember any state, and we can just send a response to each request based on content of given request. FTP Minipot. FTP was designed for transferring files over any type of network. It is state, command and response protocol. For each command there is one response. To achieve some intended action, usually few commands should be sequenced in right order. Through FTP Minipot we collect username and password, which are sent as parameters of user and pass commands. In terms of implementation, FTP Minipot is still quite simple. Command processing is easy since command syntax is not complex. In our FTP server emulation, all the complex file transfer functionalities are allowed only after successful authentication, but authentication is never successful here. By this we avoided implementation of those complex functionalities which are not needed. So protocol implementation is still quite easy. SMTP Minipot. SMTP was designed for transferring electronic mail. It is widely used and spread. Similarly as FTP, it is state, command and response protocol. There are no authentication mechanisms defined by SMTP. It instead relies on mechanisms provided by simple authentication and security layer. There are two login and plain mechanisms implemented in our SMTP server emulation. SMTP Minipot collects usernames and passwords. Again, similarly as in FTP Minipot, command parsing here is simple. Command is composed from keyword and parameters. Protocol implementation here is not that trivial. Before an attacker proceeds to authentication, there is some session initialization. Also, there are two authentication mechanisms implemented in our SMTP server emulation, and authentication data can arrive in more than one command and response round trip. So far, SMTP Minipot is the most complex from our Minipots. For sure, you were curious how much data we got from our Minipots and whether we find out something interesting from them. Here on this slide you can see basic overview of data collected during past 3 months since we have deployed new types of Minipots from approximately 1,000 of routers. In the first table you can see counts and types of captured events by our Minipots. From the first look it's obvious that amount of data captured by SMTP Minipots is 1 or 2 orders higher than counts of events captured by another type of Minipots. We think that it's caused by spam bots and searches for open relays into email infrastructure. The ratio of connect and login events is also interesting. For example, in data captured by Telnet Minipots, the vast majority of events are connects. On the other hand, in case of HTTP, FTP and SMTP, this ratio is almost balanced. So we think that Telnet is used mostly for network scans and other protocols are used more for attacks. In the second table, you can see counts of captured unique IP addresses. We were curious how many of them only connect and how many of them do something more. So the first row, all kinds of events, means count of IP addresses captured by given type of Minipot. The second row without connects means count of unique IP addresses after filtering out the connect events. And the third row, attacker count drop, means how many percent of original number of IP addresses were filtered out. As you can see, usually the percentage drop is quite significant. The only exception is HTTP, where the drop is only 10%. Surprising fact is that SMTP Minipots captured very small amount of IP addresses in comparison with huge volume of data. The sum of unique IP counts from all kinds of Minipots is not very different from global count of unique IP addresses. So it means that most of the IP addresses use only one type of protocol. For sure, there are more hidden facts in data from our Minipots, and we plan to do more advanced and sophisticated analysis in the future. Now we are in the end of my part of this presentation. I would like to thank you for your attention, and I am giving the word to my colleague Martin.